Hello everyone, welcome to this session. In this session, we will talk about the details of operators in the PSO algorithm. So let's review the workflow of PSO. We first do the initialization. We initialize two properties, the position and velocity of each particle. And this can be done randomly. Right? So after this, we can evaluate the p-best for each particle. So what is the p-best? This is the current best position of each particle. If it's in iteration 1, the position itself is p-best. In other iterations, we can find the best one with the best objective function considering the history of this particle, the historical position of this particle. And then we update the g-best of the population. So the population have the best one, the best position in this population is the g-best. And this one is updated iteration by iteration. Then we come to here. We need to compute the velocity of each particle and update each particle's position. So these two steps will generate new candidate solutions. Okay. So these are the keys. And this is what this session will talk about. Now let's first see how do we update the velocity and position. So this is the formula for the velocity update. So let's first see what we know now. Because as I have said, the velocity is updated by what? By the p-best and t-best. So let's first see the p-best and g-best. So the g-best is here. So this is what? The current best position of the whole population. This t means in the iteration t. Now we can see the p-best. This one is what? Is the current best position of the ith particle. You can see the I is here of the ith particle, still in the tth iteration. Then we can find here this VIT. So this is the current velocity of the ith particle. The with them we can find is what is updated velocity of the ith particle, and we can say this is Vt plus 1. T plus 1 means next iteration. So the next iteration, we consider the current velocity in the tth iteration and the p-best and g-best of the particle I in the tth iteration. Then we can update the position. So we can see what is xit. This is the current position of the ith particle in the tth iteration. Then t plus 1 is here. Then we can get the updated position of the ith particle in the t plus 1 iteration. We get Vt t plus 1 and x t plus 1. So this is a new solution. We generate a new solution by this formula. Right. So then we can see this is the formula I have just shown. But there are also some other parameters. There are C1, C2, R1, and R2. So what are they? R1 and R2 are the random numbers between 0 and 1. So C1 and C2, we call them learning factors. Learning factors. So both of them, we can set it to 2. So the setting of these parameters, we will cover it in the advanced specialization, not in this specialization. Note that all of the above is for one particle in one iteration. So there are m particles in the population. So I from 1 to m, we will do it m times for the whole population. And this is for the iteration t, go to t plus 1. And we will do the t iterations. So this is the total number of iterations. So by this iterative process, we will arrive at the optimal solutions. So this, what I've just talked about, is PSO when it was proposed. So in 1998, a modified PSO is introduced, and the difference is here. When updating the velocity of one particle, we can see this omega here. We call this inertia weighting factor, and this is non-negative. There are plenty of methods to set this omega, and this is even a research, right? So how to set this omega. So this omega, so what is the function of it? So clearly in this equation, the omega controls the impact of the last velocity to the new velocity, right? So when omega is large, so this has more contribution, and this provides more exploration ability of the PSO. More exploration ability means what? Means a higher ability to explore to unknown place, right? So this will promote the algorithm to jump out of local optima and arrive at a possibly better solution. And clearly that when the exploration is more, we have more effort to detect the unknown space. It causes a bit slower convergence. So if we use a smaller inertial weight, then we will carry out less exploration, but the convergence will be faster. So this becomes the update of VT plus 1 now. And we use this one to be the standard PSO algorithms. And here is the formula. Then, after knowing this, the key step, we can summarize the PSO workflow. The flow diagram is here. First, we know that one solution in the search space now is what? Is a particle, right? And its position is a solution. So we first get a population of solutions or particles. Then we do what? We track the two extreme values, which is P best and G best. Then we update the speed and position of each particle based on the formula I just introduced. Then we get the new solutions, that is the new positions of the particles. Then we use this to replace the old population. One iteration is finished. So we can carry out iteration by iteration, and eventually we can finish the algorithm. Okay, that's all for this session. Thank you very much. Bye-bye.